Let's use some applause, Bruce.
Thank you. Nice that I was allowed to join the session. It's also for me the first time with presentation here. It's very nice to hear that this is your first official Kotlin meetup, so I'm a bit honored to kind of take it on. So, who am I? I'm with Peter, who's very hands-on, doing the software development for quite some time, about 18 years. Let's see, for his technologies come by. I've actually always stayed at GBM, so started out with Java and moved on to Scala. I also did a lot of stuff with Scala, a lot of training, advice companies. But actually, for the past 4 or 5 years, it's only Kotlin. That, of course, also has a reason. So, in that sense, I'm in the mud most of the time with my fingers. Software development. I'm also a certified trainer, or TED trained. I developed quite a few Kotlin trainings, beginning, intermediate, advanced, and actually help people adopting Kotlin in various stages. So we see that companies often start out by themselves looking for information on the internet and get to a certain level, but then it kind of stops. And it says something else. You have then about 40% of potential you haven't used. It can really help you to kind of boost and get out of it, get the remaining part out of it. The thing I'm going to show you today is based on a real application I've written, mostly, where quite some advanced features I've made into it. And because it's not really, let's say, it's a very standard application, you will see that quite some, maybe stuff you haven't seen before has some great features. And I hope it will inspire you to kind of see that the advanced stuff in Kotlin really has a nice place also in the practice application. When you start out with Kotlin, probably not something you could use right away. So in that sense, I'm actually curious who I'm standing in front of. What's your experience level with Kotlin? Who is called a beginner in Kotlin? Okay, about half. Okay, still, okay. Actually, most beginners. Intermediate, kind of, right? Advanced, not probably. In that sense, haven't worked long enough to actually know the ins and outs. In that sense, that's good news because all the advanced stuff I'm showing you also really showing you in the language now how these things work. So, not only that, see syntax, you then think, okay, it's too complex. I've really dived into it and see how things work. The micro. Okay. Well, let's take a look. So the application I've written is it's not a very traditional application. It's some sort of API that exposes a query language to customers. The customer I'm working with, they actually have your data. That's when you have phone number, contract, mobile, or geographic phone. Then your operator is obliged to provide your data to a central hub, which can be queried by 112, emergency service by the Netherlands. Actually, the main purpose that providers need to provide data. These data are also used by pages like telefoongids.nl, so where you can look up personal information if you expose that also company. And before we written this application, we kind of give the whole data to these parties and they index it by themselves. But that's kind of a tricky thing when you just give away so much important data. So you're allowed to do that. So we actually moved on to provide an API for them to query everything they did. In that sense, what they use in their website still should be as useful with the API we provide them as with what they did by themselves. So it's a very flexible API, which involves also query language. Here, for instance, a procedure to query a language, which we invented by ourselves, but it's kind of makes sense. So you have here some attributes, last name, company name, and so on. You have some things like with boosting, you have things like fuzziness, with important fuzziness levels. And you also have some operators who say, okay, or, so last name Janssen or company name Janssen, and we also have kind of logical operator to build up and create, also can nest certain blocks. So this is actually provide. So that's our external DSL. Then this eventually, such a query will arrive at our server, which is made with reactive Spring Boot, Coroutines. Probably also see can dive quite into Coroutines and see what the benefits of Coroutines are. Who have heard of the word Coroutines? Okay. I think that will be a good introduction to see the power you can get with Coroutines today. Eventually, this really needs to be translated into a Elasticsearch query. Who knows with Elasticsearch? A little bit somehow. Okay, most of you know the frequency, but the query interface is made of JSON, and it's kind of less thing who mentioned. So this is basically what we had to achieve. That was the sign. So let's start out. So if you would build a system without type-safe builders, advanced builders you don't look at, then what you would have to do is kind of develop the queries yourself. There is quite a nice engine with Elasticsearch where you can do that. And then kind of translate this query using the standard Java API, which is used for that with all these ugly builders, query, bool query, and so on. Which is kind of not really related to one another, right? You really need to do the translation. It's doable, of course, but it's also a bit annoying. So it would be nice, of course, if I had a format which would be very close to what I do, but then in a type-safe way. Right? It's not, it would be nice. So, and this is basically what I was looking for. So you have this JSON, which eventually you need to produce if you like it or not. But I want to have this JSON as close as possible to a domain-specific language or type-safe build, and depending on how you call it, which provides me with the type safety I want. If I type you must and I type must with two F's, then of course the compilation. The nice thing is that some people already did this kind of DSL, so it's not something you have to invent yourself. Actually, basically, all kind of special, specific query languages, someone created in the ground. And the construct they're using are most of the time always the same, which is these type-safe builders. So what do type-safe builders do? They basically do exactly this. So they provide you some type-safe way to find a query and then do the translation to the API format which is needed by a particular client. It's the standard Elasticsearch Java client to which is to be translated. What I really love about Kotlin is that you are able to build this kind of DSL with really a few features. Actually, two features. Instead, I've done a lot of Scala. Does anybody know Scala? Yeah. In Scala, you can do really very fancy stuff, but the complexity gets out of hand very fast. It's quite easy possible that the code you've written today, you have to debug over 2 weeks, you just have a hard time, let alone your colleagues. You can make perfect DSL with Scala, and that's also what they did with many APIs, or JSON serialization and so on. But they were so complex, you can't just have code completion ID and you know what to do. You kind of really have to learn this specific language, which it's beautiful when it's there, but to get there, it's just a hell of a job, let alone if you have to do something. And in Kotlin, we kind of managed it to provide some features, and once you understand them, then you can write very decent DSL. It's not perfect, but it's just really good enough. And the feature you're going to look like is probably the one I personally had most trouble with understanding when I started with Kotlin. Maybe also because we didn't have the right material, but it's quite simple. This one is function literal with receiver. Fancy name. And then we also will look at operator overloading. Possible. I assume, have anybody heard a few of these features? Both of them? No? Operator overloading, I assume that not that's special, but this function literal thing, that's really something most probably haven't seen when you just start out with Kotlin. Okay. So, what is functional coroutine? Well, let's start out with what it's not. This is an example where this concept is not used, but another concept is used. Does anybody know how you call such a method? It's a function as argument. Yeah, lambda. Exactly. That's exactly. It's a higher function. Higher function is defined by a method that takes the function as argument. And the pattern is actually most times the same. So you do some processing here, and what exactly happens in the processing, you kind of defer to the one that calls your function. So the logic is defined for the caller, and you give some structure to do something in that. Most of the time it's with, for instance, collections. Collections then do a loop for you, and you can define how this loop has to convert, filter, over there. And collection, of course, I assume all of you have encountered high-order functions. Well, when you look at the syntax for our functions, then it's that sense always the same. So you have here a function argument, and Kotlin recognizes function syntax. So a file goes in, and the unit goes out. And whenever you want to refer to the input argument of the lambda, the file, you can use the name you choose yourself, like I did, file, or you can use the it here. I assume that this is somehow familiar to you, right? Not really shocking. Okay. Now comes the shocking part. Well, it's also not shocking, but it's very subtle. Very subtle change. So what we see here, this is not a typo. This is how this function literal receiver looks like. So instead of having an input and then some output, we have something on file. Who of you know extension methods in Kotlin? Yeah? Never heard of extension methods? Really? In that sense, you definitely have used them. Because I would say 70% of the standard library of Kotlin is made by extension methods. It's maybe kind of helpful to quickly show you how extension methods work. Because it really helps you to understand it. This is, of course, IntelliJ. You have a very cool thing in IntelliJ, which is called the Kotlin worksheet. Heard of it? Worksheet? Not everyone has. And the nice thing about the worksheet is that you can start typing codes. Yeah, sorry, you're totally right. That's it, I hope. You hit enter and it will evaluate your code. So to do very quick prototyping, that's perfect. No main methods, directly see the output. So when I develop a complex algorithm, I often use the worksheet to help me to do intermediate steps. So what is an extension method? An extension method is a very simple means to add new methods to existing types. It can also be generic types. It also can even be properties, kind of. But let's stick now to methods. So if we would like to, if you have Java and you would have a square method, right, then what you would do is something like that, I, and this would calculate the square of whatever. Right? That's how you do this. You will provide some sort of utility method where you pass in the object you want to do something with, and then you get the desired result. In Kotlin, you have the capability to say, I want int to have a square method. And the syntax is very simple. So you define the type you want to extend, in this case, an int. And instead, it can also be a generic. So it's up to you what you want to do, but this is the most simple example. Then you say dot, the method name you want to give it. And now the question is, how do I access the I? Because I want to do something with it, right? Exactly. So what you then do is this, because this refers then to the instance we have here. And our rotation would be this time this. And from then on, your my int has a square method. And the nice thing is, I also get co-completion. With these kind of wrappers, I don't have co-completion. So if others have made nice extensions for you, you probably won't find them in large programs. But with co-completion, then your ID helps you. So I say for square, and paba, I get desired result. So we hope. Interesting. Something got wrong, but yeah, really works. I will. Interesting. My worksheet is letting me down. Apparently, that's something to do with this declaration. Now, apparently, that's interesting. Okay, I have to look into that. But this is the principle. So what you see here is basically also something related to an extension method, in the sense that it's an extension method that is only available in the scope of my method here. That's what you also see here. So if you say you have here this handle, then you would say file and create here dot handle, which is actually the name of the argument we defined here. So if I would call this handle 2, then I would have to use the term handle 2. So that's more or less what it is. And what do we gain with this approach? Well, the thing we gain is that in this block, now we get some implicit context. This is called the receiver, so functionally the receiver. The receiver here is file. And file, of this type, is implicitly available in the scope of my method. So if I would use this, I don't have to do it. This is often optional. Dot set executable, this would be performed on file. And that's it. It's not more than that. So instead of having to define my own Lambda argument with an arrow, I now simply do not have to do this anymore, and I can start typing this and then use the methods that are called on this argument. So it's not more than that. Quite simple, but we'll see that this is very effective. And what's also good to know is that this is purely syntactic. If we look at the bytecode, then it's almost the same like you would see here on top. Pure syntactic. Okay. This simple construct you now can use to write, as it's called, type-safe builders. It works as follows. So you often also have actually a higher order function defined, like the one you see here. It gives some arguments. And then this would be some sort of builder thing that is mutable most of the time. So mutability is involved. And here I use a perfect writer, but this could be your payload creator, whatever, something that builds something. And what you would do is you would create the buffer in this method. So the mutable thing you would keep scoped in the method you create there. Then call handle on it. So actually the block which is passed in here will then be executed. And you would normally then return a immutable result. Because Kotlin would like to stay as much on the immutable side. There are various reasons for that. So how would you then use it? Like you see here. So write. On which would write be called? On which object? Exactly, on the buffer write, right? That's the thing we create here, which is implicitly in context. And that's a very mutable thing, write. Right? And the handling that this all nicely closed and so on would then be done by our higher order function. So, now, when you look at this DSL, you already see a bit where this feature kind of might appear? No, okay. So we have here a block, right? And this block has a bool method. So apparently we have somewhere an object, context object, which has a bool method name. When you create bool, you probably have something with a must. And when you create much of something with, well, that's a special one. Also, you have a string, and then you can do stuff. That's the more advanced one. And for now, we're actually focusing on only this particular piece. See how this is built up. It's good to know that this snippet here, in the end, must yield a match query builder. That's what the Elasticsearch client API wants, if you like it or not. This is what you need to achieve. We have this fancy syntax, but in the end, we need to have a builder with, of course, all the properties set. How this is achieved? First, you have to create, as said, some sort of mutable structure where you keep the data, which you will then pass to this builder. This is something you have to invent yourself. And we've done this here. We have some match block matches. We see really poorly to kind of make this DSL work. It's something you will never expose to the outside. You just need to keep your data somewhere. Or you need to create data structure that kind of helps you with that. This is what we also create. So match data is what we here get as an output. And in the end, name and query will be taken. So name will be taken from this string here, and the query will be taken from this query parameter here. And of course, the question now is, how do you get there? So, what we do is, when you have this match, then as said, there's always some context object. Now, context object is a match block. So this is actually what you get as an input. And what we then would like to have in this string is a match data block. This is how the implicit objects that need to help you to fill this builder are designed. Here we say .init before it was handle or whatever name you choose, and then actually the match block will be populated with the data. And this is something I actually do by defining this construct here. Then init will execute this piece of code and return me the match data block, which I then can use to fill my builder. Okay? So this is how it works on a larger level. Now we have these weird constructs. So instead of having here we have a method match must bool of this construct object. Now we all of a sudden have right away a string. How can we make a string then create such a match block, right? So this snippet here must return a match data block. If we only had this in place, we would get compilation errors. It wouldn't work. So there is a missing link there, which is also a feature we have to look at, which is Kotlin operators. Some of you have heard of operator overloading. Which ones you have used so far? Just to give ideas. Yeah, which ones? Plus, very common, of course. Yeah. Yeah, so you can do greater than, small, and all these kind of logical things. Invoke you've used? Cool. Because invoke is a bit a special one. I'm actually going to look today at invoke. The one you see with plus, greater than, allows you then to use the plus sign rather than the name plus. And invoke is a special one in the sense that it allows you to omit the name invoke. That's the whole purpose of invoke, that you don't have to call invoke. So what we have here is, we could say parser invoke, then we would just instantiate something, whatever, it doesn't really matter what it is. And because we have used operator invoke, and we need to use the name invoke, if you use another name, you would get a compilation error. So all the operators you can use in Kotlin are limited, and they really have a very clear purpose and destination. So if you want to achieve what we achieve here, you have to use the combination operator invoke. Same for plus, operator plus. Right? So what you can do then is actually call the parser as if it was a constructor of the parser, because you don't have to define invoke. But it's still a method you can implement. You don't have to provide an overall constructor, simply use a method invoke and it works. Simple, right? So all these building blocks by nature are simple. Combination is always actually kind of the surprising thing, that you can combine things to build this kind of interesting structure. The nice thing about invoke is that you can not only have it on a static level, like on the object level. You also can have it on the instance level. So here we have defined invoke in the parser as a normal method. And then we could say invoke, so we create an instance of parser, and then on parser we can call invoke, but we also can omit both of these, because, well, it's invokes. In that sense, creating some sort of construct where you simply say file and then provide right away some checks. Here, of course, it doesn't make sense, right? It would be only confusing. But for DSL creation, we sometimes need these kind of shortcuts. And what's also kind of interesting to be aware of, that you can also use invoke as extension method. So this is an extension method, remember, so we have our type we define here, this is one with a generic, then we say invoke, then we do our thing, this parse, which would then be the normal parse method we call here. And that's very nice, because then you could take, for instance, some Java stuff and create a DSL around it, if you want. Because you don't have access to original class, right? With extension methods, you always get access to everything, and that's kind of nice that also these operators work when you use them as extension methods. So, how does this now work? What is created in our class match block is an extension method invoked on string. And this is kind of the whoa thing, and don't worry, if you don't grasp it 100%, it's not an issue. The remaining stuff won't be that hard, but it's probably also a really tough thing. But maybe you see the link. Let's try, okay? But it's really no shame if it's maybe a bit too far-fetched. So we have here the string.invoke. And what is the parameter we provide to this string? So how do we call this thing, remember? Fancy name? The function literal with receiver, right? That's the concept we had before. So when you actually call a string, you then get such a match data block. That's what I also see here, because what we do in this simple method is creating such a match data block, instantiate the instance of it. And then we're calling apply init to actually tell the party that wants to do something with it of, here is your data block, do something with it. And what we do, of course, is then assigning the variables name and creator. And when you now look at, so that's interesting, name this is actually the name of the string. So this string here is this string. And this name we assign to name. So already I've filled in the first part of a match data block. And the second will actually be filled in the block above. So when you go back, so, and the second is, so parent name would be filled in here, and query would be filled in the block, or actually here, right? Because here we get a match block, and then we say query answer, but this would be filled in here. I see.
This program.
Yeah.
It's easier than a job.
Yeah. So as said, if you don't grasp 100%, remember we have only used two language features. Two languages. And we kind of combine them. And the most advanced, of course, is the string invoke, most probably, because there, first of all, we get invoke, and invoke allows us, because what you normally would do is, out of defining the string, call the method .invoke. That would be a normal method then. This curly thing we can do because this is this function literal with receiver, as we see, which will be provided as a context. And the context we provide, basically, right away in this implementation, in invoke, we instantiate this for you that you can use it. That's actually your builder. So you can call, for instance, here query on it right away. I also could still call name, by the way, on it and define a different name. I could do that. That's not really neat here. Yes? Okay. And the nice thing is when you use DSL, often you don't really have to worry so much about it. It kind of shows you the way. The reason why I show you this stuff also is because later when we look at coroutines, you will see that this pattern is also used heavily with coroutines. So it kind of helps to a little bit understand. Oh, yeah.
One is possible. So if we wanted to make query non-null, so if we wanted to ensure as type level that we always provide query parameters in our DSL, so be some kind of constructor forward. Are we able to express this in Kotlin?
In that sense, it's kind of hard because a builder allows you to set certain properties and to enforce nullability there on the compile level, of course, right? Runtime level is not in, the runtime can enforce everything. You can do validate or whatever.
I can throw an exception.
Yeah. Yeah. Yeah, it's definitely possible, but yeah, I said you could do it in the sense that, for instance, if you call bool here, then you would have to provide certain attributes. Would make DSL not very pretty, but then you really enforce that if you use bool, then you have to set these and these properties. That would be a way to approach it. Yeah. My experience with DSL is that the way you design things, you kind of type out what you want to have in the end, and then you just try and make it work. And it's really a lot of back and forth, use feature till you like it. And sometimes you have to do compromise, and then maybe your first result is okay, like the one we discussed. So if you would have to provide, does it still look okay? Maybe we do something else. So this is normally how you design. It's not that you kind of see it and then, oh yeah, after this, that. It's really kind of trial and error. Okay, so now we look at internal DSLs, which should help you at the compile level. Now you look at external DSLs, because that's what we have, right? We have this kind of query language here, and in the end, it must be converted to this. And it's highly dynamic, right? So something you can, if we have this condition, then do that. It's very dynamic. So how do you get from there to there without just writing a tremendous amount of code? So that was actually the next challenge we had to solve. And, well, you most probably have to come up with an abstract syntax tree, some intermediate layer that bridges the two worlds. This is more or less what we did. So this is our logic layer. So you have end objects that take some sort of interface, which is logic QL, let's call it like that. And you can have or conditions with terms, multiple terms. So every comma here would be an end, but those can be nested. So you can have deeply nested structures that you could produce with that. And what we then need to do is convert this string here to this kind of DSL, and then I have a structured way to kind of generate my query here below, or parts of it at least. This would be a decent way. That's what compile, or at least what program languages also do, right? So you have some code, and they have their own AST, and AST then will eventually compile into whatever, bytecode or JavaScript, like in Kotlin, for instance. That's normally how you approach it, but then, of course, on a very kind of simple level compared to real program languages. Well, would you have written parsers? Okay, cool. It's a specialism, right? Something you don't do every day, and I think you shouldn't, because yeah, when you understand it, that's fine. But you also have your colleagues, which should also be able to maintain this. Well, if you have a parser, then this kind of decision tree helps you to end up with the right solution. For instance, is your grammar simple? There's yes, it's simple. All options are possible. Is your grammar not simple? I think our grammar is not very simple. It's not like a comma or a comma separated value. It's a bit more advanced than that. So does your grammar have non-trivial ambiguities? Probably not. It's not that when you have an end on the fourth level that you have different attributes than on the first level. It's always the same. No matter how deeply I nest stuff, I always have the same conditions that apply, right? No, so then we actually end up here, and that's what you can see. Write it using Parser Combinators. Who has used or heard of Parser Combinators? Cool. Not many of you. Well, we were going to write actually parser for that, and you will see it's really, really simple. Of course, there is some, especially when it comes to recursion and nesting, it's some kind of links you have to do, but said when I started, I also didn't know that you just try and eventually you get to know. So this is actually the interface, the DSL, internal DSL we defined. Quite simple, so we have some sort of interface, and then we have the three types, term, and or, and of course they all implement this interface so that they can be nested. It's a very classical tree structure. The main model of a classical tree structure. Anybody knows what sealed means? Sealed is, yes?
Interface.
Exactly. So if you would do a when expression check, the compiler can check whether this check is exhaustive or not. Whether it is exhaustive, because it knows that no subclasses, these subclasses are available. It's really only what is there.
Yes. Shouldn't this be Warlock? It's in language.
That's not something you do in data classes as parent. So how could you still achieve that?
In the DSL that you showed, like,
very good. Pay close attention. That's right. So how could we solve that? You actually see just a feature a few slides ago. Companion, which method would be used there? Exactly. Nice. That's what exactly what I also did. So now let's write this DSL. So this is the DSL once more, my ID, and what did I do? Written a companion with invoke with a var argument, so I can provide one or many. It's like, you know var, right? So let's build up the part, not just write it all at once, just step by step, and then you will see that this is quite easy to do if you use Parser Combinators. Otherwise, it might be very, very complex. But this would be our first test. Should parse key value pair into logic AST. First name, colon, John, would have to end up at the term with key. First name, value, John. And of course, if this would be your DSL, then you're not going to use Parser Combinators. You would use split and then define it. Okay. So, I used some library someone wrote. They're just out there. I think there are more than one. Principle is always more or less the same. So we first start out with, well, we need something like a word, right? And we have some regex token, which is a word. Some character once or multiple times. And what you also need is a separator. That's a literal token, so that's really a consistent value, or regex. And now we use these two to create something like a key value pair. And then we say it starts out with a word, followed by a separator, followed by a word. Right, that's what it is. So, word, separator, word. Yes? We will look at this. Good that you, that's also Kotlin. Delegates. the separator, actually in the output, I don't want to have the separator. Right? I just want to have the first name and the last name. So what I can do then in this DSL is say minus, and then it will be a loop. And minus, what do you think this is? What?
It's unary.
Yeah. Yeah, exactly. So it's also an operator, which is called unary. And then you can write this. So I also can call it like this, unary minus. That's basically what the compiled code will call. But because it's called unary minus operator, you can look at the implementation. See, this is an operator, unary minus. I can use this code with a minus, which is of course nicer. So now we have this, and now it needs to be converted to a term. That's our next thing we have to do. Only this doesn't help us yet. Well, it's quite simple. So we say map, then we have key value. We create our term, key.text, syntax, and value.text. Then we assign this key value to our root parser, and we run the test. And we over to define. Ah, okay, cool. Ah, now I know why it doesn't work. Okay, that's interesting. Because for Java, when you have an extension method like this, it will also create a wrapper for you, so that Java people still can call it. And so when I did this square here, I got a wrapper generated square, and then that's the disadvantage with this worksheet. It doesn't really show compile errors. Something to get later on. So if I would make this square classic, and everything would compile again. No. Yeah, exactly. So I should have of course used everything. But now, okay, it's stop. So come on, you can do it. Yeah, I have. Sorry, it's just I have multiple samples files somewhere. So this is our test, right? Screen. Then let's move on and create the end conditions. So we have first name and last name and city, right? So what do you have to do? Any ideas? Yeah, so an end, right? First the literal token plus, that's what we need. And now that's something you have to know then. We have an end chain, I would call it. Then you have something like separate terms, which would be a key value pair, and end. These terms are separated and they can be changed. And then we map the thing to, and what we get here is a list of values. You see, it's actually all these terms together you will get. There is some sort of caveat. If I get only one of these terms, then I do not have to provide an end. Otherwise, I would have an end element with one condition in it. Right? I always need two. There's also a nice extension method of Kotlin which allows to reject it. I could say it's take if size is greater than 1, and if that is the case, then I can create an end. Then I have multiple because I have this constructor here. This one will be called now. Otherwise, I simply would use first. sense. A bit hard to follow. You know these kind of take, if, let things? You heard of that? Some others not. So take if is actually another way to do if conditions, which if the condition applies, you get back a non-nullable value. If the condition does not apply, you get back null, which allows you to write logic in a more fluent way. I don't use it all the time, but think here it kind of, it's very readable, right? If size, take if your size is greater than 1, and then let is a way to continue processing. Say question mark let, so this block only applies if it's not null, so it really has 2 elements. And then in let I do conversion, transformation. And else, so this would be the null case, else I simply take the first element because I'm not 1. So let's see if that works. Of course we need to change our root parser. And it's green. Then we have our final one to finish it up. So we have nesting, right? So we have braces, or conditions, and this can be infinitely nested. So we then create the OR and OR chain. Say we do here, so we get an OR literal. But we need some parentheses also. Left parent and right parent. Later I will change the values. So this is OR. This is left. This is right. So if we have an OR, then we would take an unchain as input, or the rest. Instead of an AND, we create an OR. Right. That's it. And now we also need something like a braced expression. Braced expression. And that is a left parents followed by, well, that's something you have to figure out. But in the end, you kind of call the AND OR chain. So it can be nested and kind of moves up or down, followed by the right parents. And now we need to kind of change the key value pair and say or a braced expression. Let's see if it works. So here he kind of wants to type somehow. He makes type that logicql. Okay. Interesting. That's probably not it. Otherwise, yeah, that was it. So I only want to have this element, because otherwise I wouldn't get logicql back. We'll put back this token and this token. So with minus, I kind of omit these tokens. And everything compiled again. Yep. Very good parser with, well, 8 lines of code. It's great. So I said probably didn't understand all of it. I also had, of course, to go through certain cycles, but using Parser Combinators, you're really capable of writing quite decent stuff with 2 lines of code. Okay, one more thing. By. What does the by keyword mean? Well, by is another feature in Kotlin, advanced. It's not used very often. Who has used delegates? Nobody yet. It's also most used in Android, not really on server side. Sometimes they're quite valuable. Maybe I've used lazy. So lazy lets you initialize an object once it's first time accessed, and then you initialize and have that not anymore. And lazy also is actually a delegate. So in other languages they bake this in, because in Scala you have really a lazy keyword. But here they said, okay, let's use this mechanism, and others also can profit from that. So you have some built-in delegates, and what they do is, whenever you call a getter or a setter, also or only a getter, then some method will be called. In this case, we have the observable delegates, which I would give them the property name, the old value, new value, and then I could do something with it. You can imagine Android maybe do some manipulation of a list or a form, then we get this kind of callbacks. So if you would then say temperature is 24, then code would be forwarded to the delegate and then call this. Delegate has certain interface you have to implement. It's not that hard, and then fine. So let's see in terms of time. How much time do you still have? Okay. Yeah. Also, yeah. I'm not going to dive too much into that. The only reason why it's used in this DSL is for one purpose. So what you want when you give an error message is that you can say, hey, my token, which is called word, followed by separator, has an issue. So it's kind of nice if you would get the name of the variable you declared. This is basically what they achieved with that, using the by keyword. No, you can't. No. It really wants a token to be delegate. So let's look at token. And the interesting thing is that they also use a lot of extension methods for that. Minus. I actually prepared a sample, but it's somewhere in there, and it becomes very evident. Validation test. So yeah, that's more or less it. So you have three methods that are relevant for delegations. You have the get value, and it's also an operator that really expects a certain signature, which is get value, set value, and provide delegate. Provide delegate is when actually class is instantiated and your property is instantiated, then it will be triggered. Get, of course, will trigger whenever you do a get, set when you do a set. And depending on which you have, you don't have to have all of them, you can really choose which one you have, you get certain behavior. So here, what we do is provide delegate on term. I have my test here, var, my term by term, it's my term delegate. And if I simply instantiate the class, what do you think will be triggered? Exactly. Provide delegate called by this and so on. And the same is true if I do a get or if I do a set. Not for anything. So this is the instantiation delegate term. This is access on the property. Get value called for. And then what they use in their implementation is indeed the property that is called. In this case, it would be my term. Something you could read. So, for instance, here for this on dollar name, and then you would get here the name of the variable defined here, which is my term. On term. So this is how you get some reflection information just by declaring things. So I also see these things more to be used in corner case, but here, had a meaning. Okay, another nice thing which is very easy to accomplish, but also worthwhile, we have to test this thing. How do you test it? We could use these strings, but they're kind of very error prone, right? When you forget a plus or you do your nesting not right, then it's kind of figuring out where did things go wrong. We could have used our logic DSL, but well, especially when you have to say and then provide conditions and or in the beginnings, it's something you want to have more fluent. But what you actually want for testing was more or less what you ended up here is something like this. It's for testing, but it's very type safe. You can simply say my last name, some attributes, or and then you had a brace that I do myself, but compiler helps me with that. I cannot not forget a brace because I get a compiler. So how do you accomplish that? And that's really, really easy. So that's using actually all the other operators we have. We have not, we have increment, we have not, increment, you have plus minus, we talked about them. You have infix, heard of infix? You've probably used it in tests, or maybe also in your code. It's again a very simple construct. It allows you to omit the dot and the parentheses of a method. And it also requires another argument, exactly one. That's how you can say euro and euro. And for instance, in testing DSLs, that's heavily used, where you could say should be or should contain that and this, and you can write it as if it's more natural language. Very simple. And we, of course, talked about invoke. And this is basically what we did. We just added some of these extension methods to it, and we were fine. A bit of a best kind of practice I often apply is that I do not make these methods part of my core domain. Why? If it is your core domain, so the API would expose and other people would use it, then I would say put it there. But this is only for testing purposes, and I want to keep my core domain as clean as possible. So I could have a test package with this DSL, with all the extension methods like and, or, and so on. Then I also could only use it in a testing context, not kind of polluting my code. That's kind of power you get when using extension methods. Right? Okay. So, yeah, I'm asking. This takes me about 20 minutes. I think it's interesting, but there was another speaker, and I also, yeah.
Yeah, that's another speaker.
Yes.
We're ready for now here, which is great.
Exactly. And then maybe next time we do something else.
Yeah.